dividing? Oh, multiplying. Is it all multiplying? No, it's kind of both. Multiplying and adding. Whoa, this is a struggle. All right, so if I have A on the outside, and then I have parentheses, what operation am I going to do on the inside of the parentheses? Multiplication is where it's touching here. Yeah, usually on the inside either we're adding or we're subtracting. So it'd be A times quantity of B plus C. So I'm going to use my highlighter today anywhere where I see that distributing, where I see that parentheses, and take that outside part. So I'm taking A here, and that's the part that we're going to go pew, pew. Those of you that are new to me, that's where we get that pew, pew. I think about with those arrows. Some people are doing these with bunny jumps, like they're going from A to B and then B to C. But I want to make sure my arrows both start from which term? They both start from A, because that's the part that we're distributing. Okay. All right, so A is going to be distributing, which means we're going to do A times what first? Good. A times B and A times C. All right, amazing. You guys are like, oh my gosh, Miss Morrell, we got this. We just did it in our warm-up. Soup's boring. I'm going to asterisk that because that's going to be an important part when you come back to your notes. We have 3 examples that we're going to work through today. We have one like this, and then we're going to do another little asterisk. All right. Here's example number 1. We have negative 2p squared times the quantity of, when we hear that quantity, we have that separate amount, 4p to the third power plus 6p. So we're going to take what we did in our warm-up and we're combining it not only by doing distributive, but we're going to be dealing with that variable as well. So on the outside of our parentheses here, we have a negative 2p squared. Is that a monomial, binomial, or trinomial?
No, binomial. The middle one.
The inside is binomial. This 4p to the third plus 6p. What's this just as outside, though? Just a monomial. How do I know it's just a monomial and not a binomial? It kind of looks like it's 2 things, but how do I know it's really just one part? Good. No adding. It's kind of all smooshed together. Okay, so that's a monomial times a binomial. Good. So which part am I going to distribute? The negative 2, the p squared, 4p to the third, 6p? We're going to do the whole outside part, that whole negative 2p squared. That whole monomial is going to go pew, pew. All right, now some of you are going to get really good at doing this part in your head. I'm going to write it out, especially since this is our first time. And remember, for our notes, we always want to write more on this first time, so when we look back, we know what's happening. So it's going to be negative 2p squared times, what's our first part? First term. Good, 4p to the third power. So I took that negative 2p squared, we multiplied it by the first term. What's going to happen to my second term? Good. Yep, we're going to, oops, negative 2p squared times 6p. We distribute it to both. Some of you got really good at that with the distributive property. The problem on the board for our warm-up, you guys just did the 3 times 4, 3 times 7. You didn't write this step out. Eventually, we'll get that good at this. But again, there's a lot of different parts here that are happening. So in that first one, negative 2p squared times 4p to the third power. What am I going to multiply first? Negative 2 times 4 is negative 8. And then we need to figure out how many p's are we multiplying here. Good, we add them. So if I have 2 p's and 3 p's, together that'd be 1, 2, 3, 4, 5. So p to the 5th power. All right, and then the next one, negative 2 times 6. Where do we get 8 from? We did negative 2 times 4. We multiply the coefficients first. Then we work with the p's. So over here again, we upward to those coefficients, negative 2 times 6, negative 12. How many is p squared? That's p times p, good. And if I have just p, what's the exponent of just p? Oh my gosh, you guys must have had a really good math teacher that taught you really well. Alright, so if I have another p, how many p's total would that be? 3, so p to the 3rd power. Can I combine those terms? They both have p's. Are they like terms though? No, this one's a p to the 5th and a p to the 3rd. So that's it. Crushed it. Alright, we're going to take it up a notch. That's with a monomial. Technically, you've been doing a monomial times binomials the whole year. We just haven't called it that. We're just amping it up sometimes with those exponents. Yep. Yep. But since it's a 3 and a 5, they're different. We'll keep them separate. Good. Alright, so this one I'm going to do an asterisk for again. This is a really big part. We're going to kind of have an idea, not an example here. And this time we're going to do a binomial times a binomial. So binomial means we have 2 parts. So I have a plus b. And then I'm going to multiply that by another binomial. So c plus d in parentheses. So I have 2 parts in my first parenthesis and 2 parts in my second parenthesis. So first thing I'm going to do is distribute my first part, which is which term here? A. So I'm going to take that A, and I'm going to distribute it to the part that I'm multiplying. Am I multiplying A times B? No, that's A plus B. Where does the times come in? Yeah, in the middle. So I'm going to do A times the second part. So I'm going to take this A, I'm going to go pew to the C, and take the A and go pew times the D. But that's not all we're multiplying by. It says we need to multiply by A and B. Remember another word for plus is and? Like 2 and 3 is 5. We put them together, we use that word and. So we're multiplying by both A and B. So now I need to take B and I need to multiply by B also. So I'm going to take B. This time with my arrows, I like to go below. Pew! Pew! That way it just keeps it a little organized. Alright, so we're going to have B times, what's the first part and the second part? First term. B times C, and B times D. Kind of a lot of color coding happening here. Alright, so number 2, I'm going to kind of be spacing my work out here today because those arrows take up a lot of space. So we have 2 more examples. We have example 2 and example 3. Or man, example 2 here. We have 5x plus 1 times 3x plus 6. So this is a binomial times a binomial. This part is really brand new to us, so if you have your phone out right now would be a good time to put it away, pay attention, because this part is going to be the new part of today's lessons. Alright, what's the first part, what's the first term I'm going to distribute? Good, I'm going to take that 5x, and to where do I distribute that to? I'm going to jump to the 3x and to 6. Both of those. It goes pew, pew. So I'm going to do 5x times 3x. I like to personally, when I work on this, I write out all my multiplying problems first before I find my answers. So now I'm also going to write 5x times 6. But we weren't just distributing the 5x, we were doing 5x and 1. So now I also have to distribute this 1 out. So now I'm going to take that 1 and I'm going to go pew, pew. So 1 times 3x and 1 times 6. I like to write those all out first. Then after I have them written out, then I like to go through and just do all my multiplying at once. That kind of helps me out personally. Some people, they like to multiply as they go. I find when I multiply as I go, I get kind of lost at like where am I up at top, like where did I leave off, where did I pick up. But some people are really good at that, so just do it the way that makes sense to you. Alright, so on this first one here, what is 5 times 3? 15. And how many x's would I end up with? I have an x and an x, so that'd be x to the second power. Good. Alright, 5x times 6. So 5 times 6, 30. And how many x's in that problem? Just an x. Good. Just one x. 1 times 3x. Oh my gosh. And 1 times 6. Amazing. Now for a final answer though, these are all the little parts to the answer. For a final answer, we need to now combine them, because these are all the little parts. So off to the side here, I'm going to write it out as an adding problem. 15x squared plus 30x plus 3x plus 6. Now, is that my final answer? What? We did so much work. It's not done yet? You guys are crazy. What do we have to do? Good. We have our like terms, the 30x, 3x. So 15x squared, that stays as it is because it's the only x squared. 30 plus 3, 33x, and then plus 6. So when we did a binomial times a binomial to start off with, we had a 5x plus 1 times 3x plus 6. Binomial times binomial, what did our answer end up being? Trinomial. Interesting, huh? It's not always going to be that way, but it turns out to be that way. We have one more problem. We're going to step it up a notch. You guys ready? Woo! Number 3. Number 3 makes me want to cry a little bit, and that's why we're going to learn another way to multiply later this week. I don't know if we're going to do it. We might do it tomorrow, or we might do it the next day. I haven't decided yet. All right, number 3. This time we're going to do a binomial times a trinomial. How exciting. All right, number 3, we have in our first binomial 2w minus 8. And then we're going to do it times a trinomial, so 3 parts. 6w squared minus 4w plus 3. Alright, so make sure you got that written down correctly first. And then we're going to just do a bunch of crazy distributing. Pew, 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 pew. It's going to be like laser tag. Do you guys like laser tag? It's my favorite. I'm really good at it. Being short and playing laser tag, it's key. Alright, so what am I going to distribute first? What is my first term? Good. 2w, and I'm going to multiply it to which parts? 6w squared minus 4w and to the 3. We got 3 arrows here. Pew, pew, pew. So 2w times 6w squared. 2w times good, negative 4w. Nice correction there. And 2w times 3. All right, again, some people, they just are so excited about multiplying that they just want to find our answers to this right away. And that's totally fine. Did you get it? Okay. All right, now what is our second part that we're going to distribute? Just 8? Good, negative 8. That minus 8 is really important. It stays as negative 8, and we're going to distribute that. Pew! 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 So we have 3 more math problems to write. Negative 8 times 6w squared. Negative 8 times negative 4w. And negative 8 times 3. Oh boy. Alright, now, if multiplying is not your strong suit, if that's something that you look at this and you're like, that's fine. Use a calculator. Okay, I like to use Desmos calculator. That helps me kind of visualize what's happening here. Make sure I put in my negatives correctly. If you're using your phone calculator, remember negatives, if you have an iPhone, is this one. Okay, you can't use a minus sign for negatives when you're multiplying. You have to use that negative plus negative up there. So if I was going to do 2 times negative 4, You have to make sure you use that top one there. Okay?
After we're done with
You can type it in before or after the number, yeah. Technically, it's supposed to go in after, I think, but nowadays I think they have it figured out where you can do either. All right, I like to just use Desmos, so 2 times 6, 12. And how many W's we're going to count? We have 1 W, 2 more W's, so together that'd be W to the 3rd power. Good. All right, 2 times negative 4, negative 8. And how many W's are in our problem here? 2 that we're multiplying, so W squared. Two times 3, 6. How many W's in that one? Just the one, so just W. Alright, these negative 8s, I hate 8s. Negative 8 times 6, negative 48. And how many W's will be in that one? 2 still, good. The 8 has no W's, but that W squared still has to be attached. Negative 8 times negative 4. Negative times a negative. Positive, so positive 32. W. And then negative 8 times 3. Negative 24. All right, now we need to take all these parts and put all these parts together into our final answer. Whew, how much work. This one really is. I really don't love distributing for this one. You guys will decide which one you like best. I like the other method better, but I haven't taught you that yet. So right now this feels like a lot of work to me. All right, eventually I want to write my answer in standard form. So standard form means I want to start with that biggest what? Exponent, variable, or coefficient?
coefficient.
Exponent, biggest exponent. Good. All right, so that's my highest exponent of the W's, the 3. So I'm going to start with 12 W to the 3rd power. Do I have any more W to the 3rd powers? Okay, so next I want my W squareds. So what do I have for a W squared, or W to the 2nd power? Good, I have negative 8 W squared, and I want to put my next W squared right next to it. Good, negative 48 W squared. After W squareds, W's. So what do we have for just W's? 6W and 32W. Oh, I'm going to run out of space here. And then what comes last? Good. What do we call numbers like negative 24 that don't have variables? Constants. Good. I ran out of space, so I had to throw that down there. All right, is that my final answer? Ugh, no. So much more. All right.
Can I take this?
Yeah. So I have 12 W to the 3rd power. Is there any like terms for W to the 3rd power? No. So that stays. Do I have any like terms for W to the 2nd power? Yep. I'm going to do negative 8 and negative 48. If you're not sure, it's okay to use your calculator. Negative 8 plus negative 48. We get a handy dandy negative 56. They're both negative, so it's like we're adding. 8 and 48 make 56. So negative 56 W squared plus, what do we have for some W's? Good, and 6 and 32. 38W minus 24. Or we could say plus negative 24. And then we are finally done. Holy moly, that was a really long problem. What's interesting is, I haven't decided if we're going to do it tomorrow or Wednesday, but we're going to actually do multiplying again, but we're going to use a different method. And then you're going to decide which method you like to use. I like to use the other method. This method for me just feels like it's so much work, but some people, they like this way better because it's the way they learned first. So you do you, bro.